Hello everyone and welcome to the second part of Geometry and Trigonometry. Today we'll be doing the introduction to vectors. First off, let's look at what a position vector is. A position vector gives the position of a point which is relative to the origin over here. So in this case, for this point over here, 3, 2, the position vector will be 3, 2. The number on top represents the position on the x-axis, and the number on the bottom represents the position on the y-axis. Now if you look at the orange position vector, this is -1, -1. Next, we'll be covering free vectors. So position vectors and free vectors are slightly different. Free vectors can be moved anywhere. For example, this vector 3, 2 over here is not defined by its position relative to the origin, but actually by how long and how tall it is. So for example, I can have this vector that is 3, 2 over here, and this vector that is 3, 2 over here. This is because both these vectors are 3 long and 2 tall. Another example is this orange vector over here. Both these orange vectors are still -1, -1. This is because both these vectors cause a movement -1 on the x-axis and -1 on the y-axis. That's why you have -1, -1. Now before we proceed on to look at some of the properties for vectors, let's see how to name vectors. So for example, if I have this vector over here, this is what we can call vector AB. Sometimes vectors are also denoted by a bolded letter, in this case a bolded A. In writing though, we will never bold our letters. We'll put a tilde under the letter to denote this as a vector A. Additionally, for any column vector xy, we can also represent it in terms of xi plus yj. I is just a unit vector 1, 0, and j is just a unit vector 0, 1. There are also 3D vectors where we have x, y, z, which is xi plus yj plus zk. This is the same thing except that this is a 3D vector with 3 dimensions. Now let's look at some properties. AB equals to -BA. The negative just means going in the opposite direction. So if BA is going from here to here, -BA will just be going from here to here, which is the same as AB. Next, let's look at the addition and subtraction of vectors. If we have vector AB plus vector BC, our resultant vector will be vector AC. What we're doing is just connecting the tip to the tail end. Let's say we have more than that. Let's say we have AB plus vector BC plus vector CD plus vector DE. Again, we're just connecting the tip to the tail. So the resulting vector after adding all these vectors will just be vector AE. Now let's look at the subtraction of vectors. This over here can actually be derived from this over here. But I'm writing this as my own separate formula because I find it very important. These over here are usually used for free vectors, but this over here is more for position vectors. So if you want to find the vector AB here, given the position vector OA and OB, we can take it that vector AB will be equals to vector OB minus vector OA. What I remember is the order switches around. So AB, this becomes OB and then OA. Vector BA will instead be vector OA minus OB. Now, I want to introduce you to this concept of parallel vectors. So if two vectors are parallel, this means that vector P is equals to K of vector Q, where K is a constant. Before I look at that, let's look at how to do addition and scalar multiplication for vectors. So if I want to do the addition of these two vectors, what I'm going to do is take 2 minus 1 and then 3 plus 4. And that's it. Over here, for scalar multiplication, what I'm going to do is just multiply the 4 to all of these three things. So times 4, times 4, and times 4. That's it. So if you look over here, maybe say P is vector 1, 2, and Q is vector 2, 4. Of course, this can also be 3D vectors. This over here is a 3D vector. This over here is a 2D vector. But I'm just writing it in terms of 2D vectors so it's a bit easier to see. And if you look at that, since vector P is equals to half of vector Q, this means that these two vectors over here are parallel. Now the last thing I need you to know is the magnitude of a vector. So earlier we have this vector 3, 2. What the magnitude of the vector means is just we want to find the length of the vector. How long is this vector? We can write the magnitude by putting this absolute value sign outside of the vector. If we want to find the magnitude of the vector 3, 2, what we can do is just use Pythagoras theorem, Remember, this is 3 and this is 2. So the length is just square root of 3 square plus 2 square, which just equals to square root of 13. For a 3D vector, the magnitude is also kind of using Pythagoras theorem but in 3 dimensions. So what would that look like? The magnitude of a 3D vector is just square root of x square plus y square plus z square. So hence, the magnitude over here is just negative 1 square plus 2 square plus 4 square. Here's a summary sheet for introduction to vectors. Please be familiar with all these properties over here, parallel vectors and magnitude. These are very important coming in the next few videos.